Hi, now we'll continue with the introduction to Arduino programming. This will be the second part and the continuation of the previous one. So we'll cover the basic topics, the operators in Arduino, control statements, loops, arrays, strings, the mathematics library, random number, interrupts, and the example program, which will be a bit complicated than the previous one. So basic operators, as normal C, C++ or Python programming or other languages, you have the basic equal to, plus, minus, multiplication, division, modulo division operators, then comparison operators. You have equal to, not equal to, less than, greater than, and all those operators. Then you have Boolean operators, bitwise operators, and compound operators. Moving on to control statements, these will basically cover the various checking and looping parts. So a normal if-else statement in Arduino, you start off with the if statement. So if you have a condition, and within these curly braces, if the statement condition is true, if else, if another statement condition is true, or else if none of the above statements are true, then this loop will execute. Moving on to switch case, you have switch, then choices, you have case, option 1, then statement, and then a break function after each case. So case option 2, you have statement 2, then again a break, and so on. And at the end, you have a default case. After that, you again have a break function. Then you have a conditional operator. We'll avoid using conditional operators such as these in Arduino. So it is condition, if it is true, it will execute statement 1, else it will execute statement 2. These kind of statement operators are best avoided during Arduino programming. So in loops, you have the basic for loop, then you have the while loop, you have a do while loop. These are pretty common examples. You have a nested loop, that is a loop inside another loop. You can have many nested loops inside each other. So you have an infinite loop. So to run an infinite loop, for example, you develop a system in which you need to turn on and off a light or a LED or any other device infinitely. As long as the device is on, your system is checking. So recall from the last lecture, which I showed the blinking LED example. So you can see, if you put it inside an infinite loop, as long as the Arduino board is powered, it will keep on blinking. So your functions can be made more complicated. Instead of LEDs, you can have motors. Instead of motors, you can have actually cameras mounted on the motors, and they keep on rotating. You can have a multitude of sensors which are interfaced with the cameras and the motors. So you can, for example, you can build a security system which will keep on running as long as your processor board is fine and the power is being supplied. You can always connect it to a battery supply to generate power for it. Then you have arrays. Arrays are collection of elements having homogeneous data type and which are stored in adjacent memory locations. The conventional starting index is 0 in Arduino. So declaration of array, you just start off with the data type. It may be an array of integers, so int, array name, and the size. So for example, int array, this is a variable name, array 5, it will allocate 5 spaces for your array. Then you can have alternate declarations. Suppose int array and this blank bracket equal to, within this curly braces, you have 0, 1, 2, 3, 4. So these will be automatically stored in this array. Then again you have int array 5. You can just put in 3 values inside this array, and the remaining will be kept blank. Maybe for later use, you can fill those also. Then you have multidimensional array declarations. Same as previous one, you have the data type, then array name, then the dimensions. For the first dimension, let it be n1, n2, n3. So for example, if you want to declare an array for a image, which normal RGB image, so you have 3 channels, red, green and blue. So each image will have a 2D structure, rows and columns, and there will be a depth for each R, G and B. So maybe for those types of data, you have int array, row, column, height. So then moving on to string. String is an array of characters with null as the termination. Declaration is maybe using char string. Here str is the array, so ABCD. So this is stored in str, char str4, and you can individually access each IDs. You can store A, B, C or maybe 0. So this is using the same location. If you want to individually store in different locations, so come in the same location, if you keep on storing this, the last one will be last character stored will be updated, other will be overwritten. If you want to store in different locations, you just change it from string 0, str1, str2, str3 and so on. So you will have consecutive A, B, C, 0 side by side in these locations. Another thing, you can also have a data type string. So string str equal to ABC will give you ABC altogether. You don't have to store in individual locations. So this is one of the benefits of using Arduino. So some commonly used functions of string. So str to uppercase, point to note is to uppercase, T, U and C are caps. So this has to be followed strictly since this is part of the syntax. So it changes all the characters of string to uppercase. Then you have string str dot replace string 1 and string 2. So string 1, if it is substring of str, then it will be replaced by str2. Then str dot length, it returns the length of the string without considering the null character. Then another commonly used library is the math library. To apply the math functions, the math.h header must be initially called, otherwise you won't be able to access these functions. So some of the common functions are cos, which is in double radian, then sine, tan, floating absolute, fabs, right, floating mod. So double value 1 and double value 2. So you have 2 values and f mod will give you the modular division and the result will be a floating point number. Then continuing with the math library again, you have exp, which signifies the exponential function. You have log function, this will give you the natural logarithm of the value. Then you have log 10, and you have square function, power function. First argument is the base, the second argument signifies the power. Then another commonly used example is random number. So one of the functions of this random number is random seed. So the syntax is random seed S capital. You need to focus on this one because this is the inbuilt syntax for Arduino. So random seed int v, it resets the pseudo random number generator with seed value v. So you already, the seed value is the starting point from which the random number will initialize its function. So you give a starting value, from it the random number will generate. Then random max I, it gives the random number within the range 0 to max I. Then you have random mini and max I. gives a random number within the range mini and max. Then moving on to interrupts, you have an external signal. Interrupts, these are basically an external signal for which the system blocks the current running process till receiving that signal. So basically you have two types of interrupts, one is hardware and another is software. So I'll give you an example. Suppose you're in a loop, you're waiting for a checking condition, whether that checking condition holds true or not, and maybe from an external source you are getting that checking condition. For example, you have a button or a digital switch connected to an Arduino board. So whenever you are pressing that switch, your system will blink an LED. Otherwise, it will keep the LED off. So this may be considered as a partially considered as an interrupt. So this will be an external interrupt. So as you can see, digital pin to interrupt and then the pin number. It actually changes the digital pin to the specific interrupt number. Then attach interrupt, digital pin to interrupt, then pin, then ISR, then mode. So ISR is basically known as an interrupt service routine. It has to be defined explicitly. So these are some of the more complicated functions. So we'll not focus on these interrupts and other complications. We'll just try to keep it as easy as possible. So we'll try to implement, within this lecture we'll try to implement a basic rudimentary traffic control system. So we need an Arduino board, 3 different LEDs, some resistors, maybe 220 ohm or 330 ohm, and a few connecting jumper wires to connect the various components on the breadboard. As you can see from the previous, as you remember from the previous example, we connected an LED with the Arduino board. The same process has to be repeated 3 times using different colored LEDs and at different pins. So in the last example we connected the LED to pin 12. So maybe in this example we'll connect it to pin 2, 3 and 4 side by side. So this is the sample sketch. So as you can see, prior to using void setup, we globally define a few values. Int r equal to 2. Basically we are taking 3 colors, R, G and B. We are not giving B, we have written Y. So R, G and Y, red, green and yellow. So globally we are defining R as integer equal to 2, G equal to 3, Y equal to 4. Then within void setup, we initialize the serial port at 9600 baud rate. Then pin mode, we write R and the and output. So as you can remember, the first one was the actual pin on the Arduino device, and the second one was the mode, either input or output. So since you're connecting LEDs, we'll be obviously using it as output. So R was globally assigned as 2. So this will be 2 and output. So it translates to pin 2 will work as output. And then digital write R low. So this function will initially set the value of pin 2 to 0. So it will be turned off. The same process is repeated for pin 3 and pin 4, which connect to the green and yellow LEDs. Now we define a function traffic. So data type we are given as void. So void traffic, we so digital write G high. That was G was defined as pin 3. So over here pin 3 becomes high. Then over the serial port we print green LED on go. So since it simulates a traffic signal, you'll have a go signal denoted by green, a stop signal denoted by red, and a wait signal denoted by yellow. So green LED, when it switches on, it signifies go. This will be printed on the serial port. You can obviously comment this out. Then we induce a delay of 5 seconds using this command delay 5000. So if you remember from the previous example, delay takes in input in the terms of milliseconds. Okay, one more thing, this double slash, it denotes commenting the character. So whenever you put double slash in front of a statement, it won't execute. Your compiler will skip the execution. Next, we go to digital write G low. So what is physically happening is, at the start of the loop, you have the green signal is glowing, then after 5-second delay, the green signal is off, then the yellow signal goes high. So you print again green LED off, yellow LED on, so the status is wait, then again a delay of 5 seconds, then followed by digital write Y or yellow as low and digital write R as high. So your wait signal will turn off and the stop signal will go high. The same thing is printed on the serial port. Then again you have a delay of 5 seconds, then digital write R as low. Now you have all 3 LEDs turned off and you serially print all off. Now within this void loop, you call this traffic function. So this traffic will iteratively run again and again and again till your device is powered, and you call a delay of 10,000, that is 10 seconds. So your traffic signal loop will run once, then stop for 10 seconds, then the whole loop will run once again, and it will keep on going. So as you can see over here in the image, the LEDs are glowing sequentially. We'll come to that on the hands-on. The various outputs are printed on the terminal. Now if we come back to the circuit part, as you can see, the code I showed you, I've already made the code ready. I've connected the Arduino board. So I have 3 differently colored LEDs, red, green and yellow. I have 3 330 ohm resistors. I have a Arduino Uno and I have a breadboard. I'll just connect these sequentially. Green, yellow, red. You must always remember this convention that the smaller pin is for ground, the longer pin is for positive signal. So let's check again. This row is supposed to be ground, since okay, yellow is properly connected, green is properly connected. Now across each LED we'll put up a resistor, 330 ohm resistor. First of all, since in a breadboard these channels are fused, so I'll only need one signal or single signal to connect to the Arduino. Since this was negative part, we'll connect it to ground. Now if you remember, the green was connected to pin 3, green was assigned at pin 3 in the code, pin 2 was assigned to red, and yellow was assigned pin 4. So now we have our connections ready. So 3 wires for R, G and Y and 1 for the ground. Now if you go through the code again, so you have globally declared R as pin 2, G as pin 3 and Y as pin 4. So we have implemented it on the breadboard. Then serial port, starting baud rate is 9600, pin mode R, G and Y as outputs, digital write R, G and Y as low. That is, initially at the very beginning everything will be turned off, and within void traffic you switch on each LED one at a time, starting from green, then yellow, then red. So this is basically what a traffic signal does. So we'll compile this code. So you see the code has been compiled without any errors. I'll check whether my board is connected. Yes, it is Arduino Uno. The port is okay. So the board and the ports are fine. We'll upload the code or the sketch. Now the uploading part is complete. So now if you focus on the Arduino board, as you can see, we have a reset button. So it has already entered into the loop. So we'll push the reset button so that the code execution starts from the very beginning. You see the green LED glows on. It will glow for 5 seconds, followed by the yellow one, which will again glow for 5 seconds, and then it is followed by the red one, which glows for 5 seconds. All three turn off. It will wait for 10 seconds before going again into the loop, that void traffic loop. Now same thing, if you focus on the serial monitor, you can see the green LED is on, go, green off, yellow on, wait. Now yellow off, red is on, stop. Right? So now everything is off, so it will wait for 10 seconds. Then again the loop starts from the green LED. So it's actually not required to have a serial communication for this automated traffic control signal, but for the sake of debugging, I actually prefer this thing. So you can actually, when you connect your system to a PC, you can actually see which part of the loop your code or the hardware is executing. So it helps you in debugging your code effectively. So this is it for now. Okay, thank you.